All right, welcome to the Explainer. Today, we're going to pull back the curtain on the statistics that really power Six Sigma. We're talking about how to stop relying on just gut feelings and start using real data to make decisions that actually improve your business. So think about this for a second. How do you actually fix a problem you can't even measure? I mean, you might feel like service is slow, or you might think quality is down, but without data, you're just guessing. To really solve a problem, you have to get out of that fuzzy, subjective world and into cold, hard, objective facts. And the answer? It's actually pretty straightforward. You've got to learn to speak the language of your process. And you know what that language is? It's data, statistics. Well, that's just the grammar and the vocabulary you need to not only understand what's going on, but to start asking some really smart questions. Okay, so here's how we're going to tackle this. First up, the language of data itself. Then we'll talk about the big picture versus a small snapshot. After that, we'll get into how to describe what you're seeing and even how to guess what you're not seeing. And finally, we'll wrap it all up by turning that data into a story you can actually see. All right, let's jump right into section 1, the language of data. Look, every single analysis, every decision, it all starts with the raw material. And that raw material comes in two basic flavors. So right here, you see the two big buckets that all data falls into. On one hand, you've got qualitative data. Think qualities. This is descriptive stuff. Non-numeric things like pass, fail, good, bad. It's about categories. On the other hand, you have quantitative data. Think quantity. This is the hard number stuff. Things you can count, like the number of defects, or things you can measure, like how long a process takes. Knowing which one you're dealing with is absolutely crucial because it dictates all the tools you're going to use later on. Okay, next up. So you figured out what kind of data you have. Now you need to ask, how much of it are we looking at? Are we trying to analyze every single thing that's ever happened? Or are we just taking a quick snapshot to see what's going on? And this brings us to a really core idea in statistics. The population. That's the whole shebang. It's every single product, every customer, every transaction. The parameters are the real, true values for that entire group. But let's be honest, it's usually impossible or just way too expensive to look at everything. So what do? We take a sample, a small, manageable piece of the pie. And the measurements we get from that sample, we call those statistics. The whole game is using those statistics to make a really, really good guess about the true population parameters. And here's the bottom line, the thing you absolutely have to remember. The quality of your guess, your estimate, is only as good as the sample you took. Think of it like a photograph. A big, randomly selected sample is like a super high-resolution photo. It gives you a crystal clear picture of what's really happening. But a small, biased sample, that's a blurry, out-of-focus mess. It's the classic garbage in, garbage out scenario. A quality sample gets you quality insights, period. All right, now we're getting to the good stuff. We've collected our sample data. It's probably just a big list of numbers. So what do we do with it? How do we make any sense of it? Well, that's where descriptive statistics comes in. It's all about summarizing what's right there in front of you. You know, the very first question anyone asks when they get a new set of data is, so what's a typical value here? We're trying to find that one number that kind of represents the whole group. It's center of gravity. And in statistics, we call that central tendency. So we've got three main ways to find that center. First is the mean. That's just the good old-fashioned average. Simple. Then there's the median. That's the number smack dab in the middle when you line everything up. Super useful if you have some crazy high or low numbers, what we call outliers that might throw off the average. And finally, you have the mode, which is simply the number that shows up the most often. Each one gives you a slightly different angle on what typical really means for your data. But hold on, just knowing the center of your data isn't the whole story, not even close. Imagine you have two archers, right? Both of them, on average, hit the bullseye. Sounds great. But one archer's arrows are all packed tightly in the center, while the others are scattered all over the target. See the difference? That spread, or dispersion, is just as important as the center. It tells you everything about consistency and predictability. And we've got a few tools for this. The range is the easiest one, just the difference between your highest value and your lowest. But variance and standard deviation are way more powerful. They basically tell you, on average, how far away each data point is from the mean. A small standard deviation, that's gold. It means your process is tight, consistent, predictable, exactly what you want in Six Sigma. A big standard deviation, that's a red flag. It screams inconsistency, variation, and potential problem. So once you start plotting your data, you begin to see its shape. In a perfect world, in a process that's totally stable and predictable, you get this beautiful symmetrical shape called the bell curve. You've probably seen it before. Right here, the mean, the median, and the mode all line up perfectly in the middle. This is called a normal distribution, and it's kind of the gold standard we're often looking for. But of course, the real world is messy. It's rarely that perfect. A lot of the time, your data will be skewed. A positive skew, like you see here, has this long tail stretching out to the right. What causes that? Usually it's a few really high values. Think about a couple of customer service calls that took way, way longer than average. Those high values literally pull the mean, the average, over to the right. And yeah, you guessed it, the opposite can happen too. A negative skew has that long tail going off to the left. This is caused by a few unusually low values. A good example is test scores. Maybe most students did really well, but a few did very poorly. Those low scores are going to drag the average down, pulling the mean to the left of the median. Just understanding the shape tells you a huge amount about what's going on. Okay, let's take a big step up. So far, we've just described the data we can see, our little sample. But now for the real magic. How do we use that tiny snapshot to make confident, rock-solid statements about the entire population? This is the leap from just describing to actually inferring.
This right here is where statistics becomes a superpower. Inferential statistics is all about using that sample to make educated guesses or inferences about the whole population. For example, maybe we test a sample of 100 light bulbs. We can use that data to say something like, we are 95% confident that the average lifespan of all our light bulbs is between 790 and 810 hours. See what we did there? We can make a powerful decision without having to test every single bulb that comes off the line. That's a game changer.
Okay, last major section, and this is a big one, because all this number crunching, all this analysis, means absolutely nothing if you can't communicate it. And the single fastest way to get your point across, to turn a boring spreadsheet into a real aha moment, is to draw a picture. And that's really the heart of it, isn't it? Our brains are just wired to see patterns in pictures way better than in a table of numbers. I mean, think about it. A good chart doesn't just display data, it tells a compelling story. In fact, for most problem-solving projects, making a chart is the very first thing you should do. And choosing the right chart is everything. A box plot, for example, is like an X-ray of your data. It gives you a fantastic summary showing the range, the median, and any weird outliers all in one glance. A run chart is your time machine. It plots data over time so you can instantly spot trends, shifts, or patterns. And the Pareto chart? That's your prioritization tool. It's the 80-20 rule in a picture, showing you exactly which few problems are causing most of the pain so you know where to focus your effort. Now, as you dive deeper into this stuff, you're going to start seeing these symbols pop up everywhere. Don't let them intimidate you. Seriously, these Greek letters are just shorthand. They're a quick way to talk about the things we just covered. So when you see mu or sigma, you know we're talking about the true but unknown population values. And when you see X bar or S, you know we're talking about the estimates we got from our sample. That's it. And really, that's the whole journey we've been on in this explainer. We started with the basic types of data. We talked about the difference between a small sample and the whole population. We learned how to describe the data you have, and finally, how to visualize it to tell a story. This is the toolkit. This is what lets you stop guessing and start knowing. Think of this knowledge as a new lens for your camera. It completely changes how you see the world around you. Every process, every team, every system in your business is constantly generating data. It's telling a story about how it's performing right now. So the only question left is, now that you can speak the language, what story is your process waiting to tell you?